So welcome safety enthusiasts to the SRES Fireside Chat. I'm Jody Nelson.
I'm Gokul Krithivasan.
And I'm Bill Taylor.
So in our last Fireside Chat, we discussed about the needs for general intelligence for autonomous vehicles. If you haven't seen that yet, it is available in full length on our website, sres.ai. Today, we're going to switch it up a little bit and talk about something different. We're going to talk about AI-based software tools, which are used in automotive for development and kind of what the impacts are there. We've had a number of customers and people reach out kind of asking, hey, what do we do with these AI-based software tools that are popping up all over the place? So today's discussion will be focused on that. So before we dig into, I guess, the specifics of AI-based tools, maybe Gokul, can you explain what kind of standards out there in general for, would say, non-AI-based software tools? So what do we do in automotive right now for software-based tools?
Yeah, very good question. I think first of all, we need to think about how can tools potentially introduce errors, right? In functional safety, we talk about how we can have maybe hardware errors or software errors, but a really good topic inside 26262 and Part 8 Clause 11 is software tools are also software. Therefore, what if they have any systematic errors that can introduce errors into the product? So they have Part 8 Clause 11, that's confidence in use of software tools. So you basically take an inventory of all the software tools that you use, figure out a tool impact, whether it's safety critical or not. If it's not safety critical, you're not using that tool for any safety related purpose, you can basically say, okay, that's something that I don't have to worry about. But if you're using the tool for, let's say, testing or for compiling your code, then there is an impact on safety. For that, there is a way of approaching it through what sort of confidence do I have in detecting some of these errors, right? So there are different levels, one, two, and three in terms of error detection capability. Basically, a low, medium, high confidence. It's subjective, but it's a very arguments-based sort of thinking on how these software tools can be protected either with some internal vendor processes that can improve these tools, or maybe downstream, the output of the tools have to be reviewed, right? Or there are other downstream tools that can look at it. So the standard really gets into that. They from a methods perspective, they think about, okay, you've used this tool for a long time, therefore maybe you've built some confidence in using this over a long period of time. Or you look at the tool development process itself. If it's a third party, they've probably developed it according to some development process. And you can also validate the tool, right? You're going to install it in your environment so you can validate that it's actually working appropriately or through a safety process. So the 26262 standard has really good guidance on how to go about qualifying your tool in using while you use it in safety critical applications.
Yeah, so I guess Part 8, Clause 11 is what you mentioned. It gives us a means if a tool can impact safety in some way, that there's some level of rigor placed on it, right? Now, I guess before we get into what that means for an AI-based software tool, I don't know, Bill, can you walk us through what are some examples of AI-based software tools
Yeah.
that you see, at least with your customers?
Yeah, so it's interesting because there's just a proliferation of AI everywhere. And of course software, tools for development are no different. So just as every time you open up a newspaper or look online, it's AI everywhere. It's the same in the tool space. So we know of organizations that are using tools, or AI-based tools, just as an example, to write requirements, including to write safety requirements and to link them together and put together requirements hierarchies. Of course, that's at the center of safety argumentation for functional safety in particular. There are companies that are using AI to develop and perform safety analyses, typically in a kind of a pilot approach. So not necessarily all these are like full bore ready for prime time, but there's organizations that are working on that. So safety analysis, requirements development. Also, a lot of times when we start talking about things that are related to the test and verification, validation of autonomous systems, a lot of the scenarios themselves and even the environments for test and simulation. Those are all powered by AI. So there's a lot of AI there as well. And obviously, when it comes to just software, not only things that are how can I say fancy and advanced like autonomy, but also just in general software development, AI coding, AI tool for developing code, for reviewing code, for developing test cases. And so all of the, I would say the entire tool chain across product development, across software development, is now influenced by AI. And I don't think we know exactly where that's going to go. Some of those methodologies may work better than others. I think the future is uncertain in terms of exactly how it looks, but there will be AI in tool chains. And so we have to have some way of managing those and assuring from a safety point of view, assuring that they're safe.
Yeah, I think I've seen something similar. I spoke to a manager not so long ago, and I just asked, how many of your C developers or C++ developers are using AI? And basically, this person said everyone. It's
Yeah.
kind of starting with that, and then, starting with the AI, creating the code, and then kind of reviewing it by hand. So,
It's similar to the question of how many kids in high school are using AI to write their essays, right? I mean, we don't know, but let's assume it's a high number.
yeah, it's interesting even with that. Not to diverge too much, but my son, he's only 12, and they use Google Classroom, in their school, and probably a lot of schools use that. They use Chromebooks, and he had to write some kind of paper, and he was told not to use AI, which he didn't. But even within the school provided computer, it allowed you to right mouse button to use Grammarly. And Grammarly, it doesn't
Yeah.
only just do like definitions or spell checks, it also suggests some things. And of course, the language, I mean, for the most part, the framework was his writing, but his words he wouldn't use. So it was kind of a thesaurus on
Yep.
steroids, and he got kind of knocked for it. In the old days, we'd have to pull off the dictionary and thesaurus, off the shelf and kind of look up words. But it's just too easy to use. And, even my 12-year-old's, kind of deep into this. So I guess I want to circle back to you, Gokul. I mean, you kind of walked us
Yeah.
through, and I think even if you talk about ISO 26262, I don't think Part 8, Clause 11 has even changed much from the first edition, 2011, going in 2018. The language, the kind of format of that process of software tool qualification is very similar. What does this mean now? Bill gave us a list of kind of AI-based software tools. What he mentioned, some safety critical, right? Like a lot of these, if they go wrong, it could go wrong in a bad way. So what do you see? Like, how is ISO 26262 equipped right now, that 2018 version, to handle this?
That's I think the core of the challenge. Even when we look at products that use AI, right? Let's sort of keep the tool aside for a moment. Let's say ADAS, ADS, we need synthetic data, right, to prove these out. And there are a lot of tools which are already AI powered of the simulation space that we've been using. Also in 8800, particularly with the data pipeline and the ML pipeline, we've been using these tools for many years now. And when you look at these standards, 8800 or 21448, the SOTIF and the AI safety standard, they simply just point to Part 8, Clause 11 and say you should follow the ISO 26262 standard. And as you mentioned, it's not really changed much. It's not really evolved since it was first released in 2011. So I think the principles in Part 8, Clause 11 are really good, right? It's very much inventory all of your tools. Let's systematically evaluate how this tool can introduce error, and let's fix them. But the challenge with AI-powered tools is errors that are more obvious to catch with more traditional tools are not going to be very obvious, right? When these tools hallucinate, when you're using these tools for writing requirements, and it'll give you something plausible that seems plausible, but it's going to hallucinate and give you something, which means it puts a lot of burden on the reviewer. Earlier, we would say, oh, if the tool failed, then a reviewer should be able to catch it. It will not pass a inspection review. But as these tools get better and better, the review becomes more important, right? Also, do you then have a different review checklist for reviewing AI powered tools? I think particularly when these tools are going to keep getting better and better, and they're going to, right? These models are getting better and better. They're going to be harder to review, right? So that's the sort of challenge where we can't use these scales of judgment and subjectiveness. We need something more rooted, it's almost like a safety argument that we would make for a product because these tools have become more complex, right? We need probably a similar sort of argument for that. That's the challenge, really.
I think within the standard, we do this first step of kind of classification, can it impact safety or not? So I think that question doesn't change. I guess how about what do you see for the second one, like tool error detection? Like what is our feeling of how confident we are we were able to detect it? Is this going to automatically just everything is going to be kind of the worst case scenario, or
I think so, right? Because we can't build the same level of confidence, we need to start conservatively, and that's TD3. And therefore, I think most AI-powered tools, I think we need to start with a TCL3 low confidence level and then build up the argument, right? To be able to use. I think that's when you know less, you want to be more conservative.
Yeah. I mean, I think also, I mean, just to support that, I agree because it's a kind of a new world, and it's a new world partly because I think when we get into the detail of, why did a tool fail? How did a tool fail? We have a mental model, all of us, based on decades of history, which is around tools having potentially bugs, right? And so bugs are, bugs are traditional software kinds of artifacts. They're mistakes in the tool, and they have some relative repeatability to them, right? Where we say, hey, here's what happens, when I put command X in, then I get erroneous output Y. And so they can be a challenge, but we can find them, right? We have some intuition for what they are. And I think AI tools now add to the scene bugs or flaws or malfunctions, which are less like our traditionally defined bugs and more like hallucinations, right? I mean, and they essentially are hallucinations to some degree, where we can say if we're using, AI assistant for coding, we can give it some command about what to do or what kind of functions to write, and it can write them. And with one command, it can write them really well and have all the variables in memory right. And the same command or very similar command to do the same thing can suddenly create something which is a convoluted mess. And and there's not an obvious reason why, right? Why one request led to a good outcome and another one led to a bad outcome. There's this inherent unpredictability and difficulty to explain. So I think we're all worried about that, or sort of thinking through that for safety in the product space. But I mean, the tool space is in some ways no different. It's similar that as we went from 26262's idea of malfunction, when we go to ISO 21448, we talk about functional insufficiency, right? It's less about a bug and a glitch and more just like something it really wasn't able to do. And there's kind of an analog, I think, with tools that are powered by AI.
yeah, I mean, you bring up a good point. And I guess before we kind of talk our own theoretical ideas of how to handle this, um, there's a lot of discussion here, and especially Gokul with the 26262 approach. I mean, Gokul and we have a lot more standards now available since 2018, right? And especially in ADS space with, AI safety of the 8800 and, 5083 with ADS safety cases and things like that. Are there any standards within automotive or that you know of that kind of addresses maybe a little bit on this AI-based software tools?
I think so. Maybe not perfect, but I think it's a good start. So within 8800, just to be clear, right? The 8800 is our AI safety standard. Within 8800, they specifically say in the scope that it doesn't cover AI-powered tools. So they only focus on the ML components within the car, right? But then there are some really good principles in 8800 you can still use, right? Because even within these software tools, there are ML models, and ML models are developed through a process, right? You train the model, you validate the model, you test the model, and then you're basically doing something similar for the data that you need to even build the model. So it's very process heavy. So we are starting to see process FMEAs come back into the fray, right? This is, of course, something that as technical people, we don't really use process FMEAs, we use more design-oriented FMEAs. But here, because it's very process-oriented, and a good process of building, training, validating these models could actually give you confidence that the output is good, right? So you can then start using these process FMEAs. There's good academic research on this. There are also industry players who are talking about this. Having good process FMEAs to say, okay, did I really train the model appropriately? Did I use the right sort of validation approaches? People are involved in labeling supervised the data sets for the supervised learning. Did they label appropriately? Is the ground truth okay? So I think process FMES can be helpful, but again, this is not a perfect solution. It sort of goes. It's a good fix in the meantime. However, the 8800 standard does point out when there is domain specific guidance, or if there is guidance in any other standard, then use that guidance, right? And that's where I think like 5469, which is a new standard that came out, that could be something that can. I know you worked a lot in that sort of space, so maybe I'm interested in your thoughts. Like, could we
Yeah.
use like 5469 for something like this?
Yeah, that's good. So yeah, the ISO IEC, and it's actually a TR, so technical report 5469. So it provides guidance. So I mean, one disclaimer we have to make: there's no shells in there, there's no requirements to meet, but there is some good guidance there. And those who are not familiar with the 5469, it is AI with functional safety, and it balances, using 61508. So the IEC 61508 is kind of the basis for the functional safety discussion. Now, they do have a classification technique within the standard to kind of determine what path you go into, and they have this kind of flow chart. Now, they don't really separate the effort between AI and embedded system, so on board your vehicle, on board your robot, or whatever the product is, because it is agnostic to industry. They don't separate that kind of activity from what you'd need to do for an AI-based tool. So basically, AI-based tools, they have what's called like a level B, I think is what it's called, within this classification. And then you can be a class 1 or 2, or 3. But in that path, they kind of walk you through the same process, whether it's embedded AI software or if it's an offline tool. And the first step is apply existing standards. That's kind of a generic statement. So what risk can we reduce using existing standards that we know kind of true and already proven in use in some degree, standards. So, you already mentioned 26262. So Part 8, Clause 11, that would be kind of our existing standards now. The next step, they want you to kind of examine the gaps. So what didn't Part 8, Clause 11 cover in that process? And then kind of evaluate the risk. So what's remaining out there? And after that, then the standard is a little bit more vague or a little bit more open and just says, well, you have to apply additional mitigation measures. Going back to the statement you said before, I mean, one of these mitigation measures is a PFMEA. So adding a process FMEA in it, I think it would be good to have some discussion on, process in general, because I think a lot of the things that we're going to see is going to be process oriented around this. Another thing is, using an AI lifecycle of some sort. So you mentioned about Part 8, Clause 11. There we have, 4 main techniques to use to increase our confidence. You mentioned, kind of confidence in use, and you can do a verification validation kind of activities. But one of the more stringent ones there was, well, apply an actual safety standard, right? So use a safety standard to develop the tool itself. And that's where 5469 would also kind of say, well, was the tool, and maybe we should be asking vendors, are you using some kind of AI safety lifecycle, some kind of AI lifecycle? And there's various standards out there. In 5469, they kind of give the 3 pillars. You need something in the life cycle dealing with the data, right? Because we have training data, and we have validation data, and you have test data. So adding rigor there will help improve. So basically kind of pointing to quality, process in developing the software itself. And then the whole, how you test and verify and things like this. So, and there's different testing they could do. I mean, they can do performance testing, all these kind of things we talk about with AI, on embedded software, they can do as well. Detecting for overfitting and examples like this. And it also talks about, confidence in use. So obviously that's difficult to argue if it's a first time you're using this tool, but as time goes on, maybe that's something we can look at more. But also locking down configuration management. And, even in the old days, I remember going to conferences and some of the larger tier one suppliers were presenting that they kind of locked down tool chains. So if you're in a safety path, whatever tool chain you started with, whatever versions, that's what you kept for the whole entire development. We didn't just switch to the next, shiny rock. We locked down that. So having configuration management, these are kind of things that it talks about. And we see, even expanding outside of 5469, things like EU AI Act, a lot of discussions on human in the loop, right? Like human in the loop is always going to be a big part of it. I think something that we'll definitely see as an indicator here.
Just a quick note on process FMEA because you guys both mentioned it. I mean, I think it's a good example of the nature of what's in a lot of these standards and the right sort of frame of mind to use them. A process FMEA is not a magical tool where you turn the crank and everything becomes safe. It's really a place to record your best understanding, and then that's how safety analysis in general is a place to record your best understanding of what could go wrong, why it could go wrong, and what control measures you have in place to make sure it doesn't go wrong. And that's kind of a simple summary. There's like some true technique to it within there, but when you have any process, a process FMEA, again, it's not magic, but it is a place to record these ideas of potential issues and your solutions to those issues. It's useful for an auditor, for an assessor, for sure. So it's a good compliance document, but when it's used well, it's also just a good document to get everyone on the same page. And what we find always, I know you guys have seen this as I have many times, large organizations tend to have different people in different parts of the organization making different assumptions about how we're being safe, right? So a process FMEA always for AI tools and for manufacturing and for everything else, it's a great way to just get a larger group aligned on here are the potential hazards, here are the countermeasures we're going to put in place to mitigate those. It's a little bit of like reappearance of one of the oldest tools in the book, right? Way back in the 80s when quality was really being driven hard in automotive, process FMEA was a big part of that. And now here in the advanced world of AI, we see the exact same thing, and that shows it's mutable, it's adaptable to this new world that we're in.
Yeah, I attended a webinar recently, and they're talking about this, and a lot was on the process. I mean, the moderator kind of made this one statement that you can't 100% trust the output of a tool, especially like an AI-based tool. So it's really the process that has to be built to catch 100% of any potential errors. And their view was the wrong approach would be to say for an organization, well, you can't use AI tools, right? Like, and again, this is their opinion, so I'm just kind of repeating what I heard in this conference. Um, you can't just tell your employees, well, don't use AI tools and, kind of hope that's your solution. So it wasn't about limiting employees from using AI tools, but what they saw, it's the organization's responsibility to ensure there's a process around catching for these errors. So you have to build a process that adds enough sufficient controls and measures around it to detect and mitigate any kind of errors that could be produced. So I think it kind of relates to the PFMA. Within the PFMA, you may find these controls or measures that you need to add to your processes.
Absolutely, and I can't agree more with this idea. It's a naive idea, especially for any large organization, to simply say, "Hey, no one will use an AI tool." It would be roughly akin at this point to saying like no one used the internet, right? I mean,
Yeah.
it's just not going to be the reality, right? You can say don't do it, but the reality is people are going to do it, and therefore we have to have, as you just mentioned, I couldn't agree more, processes, frameworks to sort of take those AI outputs and where they need to be safety assured to safety assure them. So it's not that we do it blindly, but also I think it's the most blind thing we can do is simply command the tide to not come in. I mean, the tide comes in no matter what we command. We've got to manage it, and AI is the same way.
Yeah, and there are a couple of ways to think about it, right? Like one, like the optimistic sense is like these tools provide a lot of velocity, right? They can transform, they can help you do a lot of things faster, better. Therefore, I think you need to sort of channel that a little bit. I think using a tool like this, to Bill's point, helps you understand pitfalls before and also helps you maybe understand where the tool is going to be really, really good, and therefore double down and use it more there. And where the tool may not be as good, and therefore maybe let's not jump there as fast. Because the counter argument, the pessimistic viewpoint, right? If you're sort of being cynical, it can break things really fast too, right? If you're not careful, like the same transformative power it gives you to create also can sort of really get you off the rail. So I think it's helpful to sort of also be aware of those challenges.
Yeah, I mean, and I do want to talk a little bit kind of the human in the loop portion of this because it does pop up a lot, especially with AI in general. I don't know, Bill, do you see these AI tools more as a co-pilot to like help support our work? Is it more like a disruptor where we're just going to like fully depend on it? Like,
Yeah. Yeah, it's a good question. I think if we talk to some futurists out there, there's people who really see like I don't know, one AI tool doing the writing and another doing the reviewing and a third AI doing the testing and maybe the requirements derivation and there may be, we might all just be able to go home and read a book or go to the beach or whatever. That's a vision that's out there with some people. From my point of view, I think the practical experience that we see in the field, talking to many organizations and just with some knowledge base of how things have evolved. I really see AI as something of a co-pilot, maybe as a follower of instructions or a junior coder who helps. I still think it takes a software expert who's responsible for that code to really direct what happens, to write the prompts, to do basic review on what comes through. So I do see it more as I like the word co-pilot. Co-pilot's a good responsible word because it's meant to reflect this idea that although it's helping, although it may be writing code, it's not doing it all alone. It's doing it in concert with and at the direction of a human being and hopefully someone with some expertise in these things. So I like the co-pilot model. I do think there's some new and interesting means by which we would say some AI tools are developed to generate code, and others are developed to monitor code or to review code or to provide feedback on whether the code is well constructed. So I think there's more of a role than just writing the code. There's additional pieces in the puzzle that where AI can help, but I still think the co-pilot idea or the co-pilot slash assistant idea for me is
mhm.
it's the most practical, most useful mental model. I think it reflects the reality today, and I think that goes to show that it still takes some of our it still takes some of our human ingenuity or human capability to push things forward. I think if we wanted to really step back and say it's all done by AI, we start getting into questions about, well, what was our human intent for writing this in the first place? And I think it's very hard right now for AI to go through that complex higher level reasoning and discussion that we would have, at the very beginning of a project, right? And we're saying, hey, what's really our goal? What are we trying to achieve? What are our next steps and how do we break that into milestones? Until AI can translate from there down into writing code, I think, knock on wood, there's still some role for human software experts and should be, especially where safety is concerned.
Yeah, so yeah, more of a co-pilot view. Kind of intensively, we have to verify kind of the outputs. So I don't know, go cool. Like, how do we validate or verify these kind of outputs from these AI assistant tools? Especially when we're using these outputs to feed into our safety applications. Like, thoughts on that?
Yeah. So I think if you think about it, some of this output could actually be part of your design, right? So I think in those cases, then validating in the target environment the output and subjecting them to the same type of tests that you have to sort of carry on the output of human like engineers. It's sort of weird saying human engineers now that we have artificial intelligence engineers, right? I think on the output of these tools, and we talked about this earlier, because we can't assure like how these work in the internals, we need to have the rigor and really testing if in the target environment, in what we want to build, is it providing the right performance, right? It's similar to sort of how we would validate any other output that sort of becomes part of the design. Another area where I think will be useful, again, this is just my thought. I'm interested in your thoughts also on this. It's proven more that AI tools are better on the review side, actually building test cases and helping. So not only a design co-pilot, so to speak, but also a reviewer co-pilot. So maybe we need two different sort of models or tools that are not subject to the same biases, or this comes from the same sort of place. Maybe that could help us confirm that it didn't do something wrong, right? The likelihood of two different models being provided some objectives, being in alignment with one another, maybe again, that's the sort of space where
Mhm.
I think we need to do more research, and we need to do more work to try to nail that sort of piece down.
And I kind of feel from your response, it's a similar question we get with autonomous vehicles, right? Like, when do we have sufficient evidence? When is it safe enough? I don't know, Bill, what do you think? I mean, as far as tools, I mean, and you probably get this question 2, 3 times a day on autonomous
Yeah.
vehicles, right? Like how many millions of miles and things like that. Well,
Yeah, sure,
we
sure.
convert that into an AI-based tool. What does sufficient evidence look like?
Yeah, I mean, so it's a really good question, and I think there was a time, a decade ago when we thought, well, that's a crazy question. We'll never figure that out. But I think for autonomous vehicles and for AI enabled moving things, right? Robots, cars, and trucks, and all the rest. We do have now frameworks, especially as you all know, I love the SOTA standard, the ISO 21448. This framework of verification versus validation, or the known and unknown scenarios, and being able to drive through those with a little bit different thinking for each one, I think is very useful. It's very useful for the product, right? For the autonomous the function. But I think there's a similar idea or similar framework that we have to carry forward with tools as well. So the summary of that framework to try to summarize a couple hundred page standard into a few lines in a short video. Um, we have two concepts which are not in competition. We pursue them both. It's not either or, but both of these are necessary. And one is that we look at known scenarios for an autonomous vehicle that might be various configurations of a road, an intersection, places where people could stand, traffic lights, and time of day, and so forth. And we want to show that we're safe in all those known scenarios. In the tool world, we would interpret that if we wanted to kind of extend that idea into tools. We would say, well, here are all the use cases that I can pre-configure and put in and say, here's my validation or my verification test suite with things that I put in as a knowledgeable human programmer who says, here's how I would run the tool through its paces through a set of test cases. There's then separately and in parallel the idea of unknown scenarios, right? And the idea that we want to make sure that we're not encompassing problems that were not anticipated, even though we ran our full battery of tests. Did we see something that was unexpected when the tool was just normally operating? And so that in the autonomous world is a question of gathering enough miles, enough hours, and then showing statistically that we're at a very low level of incurring hazardous cases in that world. I think there is then the analog for that for tools testing and tool qualification, so to speak, is just the long-term battery and usage of tests. It's kind of blends the boundary between tool validation and confidence from use. We just want to really see that when we use this tool in practice for many hours, for many use cases, for many applications, that we see zero errors, or if we do see errors or hallucinations, that they're driven to a low enough level. And we should define that level and talk about how low is low enough, what's acceptable. That's a kind of a SOTIFY idea. That's not a standards idea that's currently applied to tools. But I think AI brings forward this idea of the unknowns, that we can never fully verify anything. We have to validate by getting a wide sweep of test cases in essentially an uncontrolled environment, and just be continually monitoring for correctness at the end. But all that for me falls back to, and I think this is what we have, right? We have standards that walk through how we do, as Gokul mentioned earlier, tool qualification, tool confidence levels from 26262. Those have always been really just a framework, right? There's no absolute demand of here's exactly how you would know that a tool is good enough or not. That they're a framework by which you would evaluate, and I think those can be used to make these kinds of really weird, hard tool judgments, even in the AI world. We have to populate it with our own understanding, right? But the framework is not wrong. It really needs to be adapted and upgraded to fit our needs in an AI world.
Yeah, and also I think these tool vendors, I think, should be aware of that, right? I think earlier it used to be just out of the box tools, right? Could be a node locked sort of computer tool or a SaaS tool that's out there, and you have to sort of customize it and use it the way you want to use. I think in many of these, what we are seeing is like the term of like forward deployed engineer, right? The tool vendor builds it, but they recognize that it's not done until they've fine-tuned that tool for the environment. And to your point, Bill, maybe there are some acceptance metrics that these customers have to build first, like what is an acceptable output of this tool? Maybe what would you accept from an engineer, right? And then subject the tool to the same type of metrics. And these tool vendors, I think, will be in a better position to then fine tune in the customer's environment to get there. I think that'll be sort of an interesting space to monitor.
I really like this idea, Bill, that you guys have been mentioning, kind of putting a sort of twist to it to some degree. I mean, it doesn't fit exactly in, but I think there's definitely ways we could see like putting metrics around it, right? Like
Yeah,
KPIs of some sort, or SPIs some sort, to monitor.
absolutely.
So I think what we've discussed here, having a process kind of around it. I think we've all agreed human in the loop, some aspect of human in the loop there, and maybe defining some kind of metric of some sort over time where you can provide confidence in it or evidence that we believe it, meets safety and quality properties that we'd want for it. I guess in that sense, maybe a tool could be certified, or I don't know if I want to throw out that term, or at least assured or something
Yeah.
by either third party or internally.
I think, I mean, for sure they have been in the past, and I think even with AI tools, they will be in the future. I think some of the things we're talking about now are, from my point of view, like digging around in the weeds of how that would really be done. But look, I think if we were to fast forward 10 years from now, what would we say that we can only certify or we can only develop with non-AI tools? There'll be no such thing, right? Non-AI tools will be in a museum somewhere. Everything we touch on a screen is going to have AI inherent within it, and that creates a pretty weird world. But yeah, I think we have to go forward with all of our good ideas of safety. They need to be adapted to an AI-driven world because that's the world that we're living in more and more by the day.
Yeah, and I mean, we have this expectation for, all of this rigor we have to put on an embedded software onto the vehicle. I mean, some of this, it sounds like we have to translate a little bit down to the tool vendor as well, right? Like these AI processes or life cycles and things like this. One thing we haven't discussed, and I think it's important just thinking about now as we talk about embedded software, and we talk a lot of times about responsible AI and those aspects, those key terms, kind of explainability and transparency and fairness, things like this. We know EU AI Act and other governments will have kind of enforcements on that. How would we ensure those kind of responsible AI aspects within a tool?
I, I mean, I'll take a crack at this. I'm interested to hear what Gokul has to say. Also, from my point of view, I think we can show with metrics and with testing outcomes with respect to fairness, outcomes with respect to robustness. I think transparency is always the hardest part. The transparency of is not a natural idea within the world of AI. We can try to force it to the fore, and we can try to do what we can to sort of make it transparent enough. But I do think that if we were to ask why an AI tool made a certain decision or had a certain outcome, the answer is just buried in all those many zillions of model weights, and sometimes it's almost not possible to make clear decision, right? It's not a linear rules based piece of code that steps through a bunch of and or statements and reaches an outcome. It's a weighted construct that resists simplification, resists interpretation. And so I think that doesn't mean we can do nothing, right? There are ways to make what we did transparent, how we trained a model transparent, what were our objectives. So there are transparency we can put in for our human defined inputs. Um, but the output transparency output for AI, I think will be a long term challenge, and there's no easy solution to get there.
Yeah, I think we need to be very aware. I think the application, whenever we talk to these sort of companies, right, either they're the vendors or the users, the application, the use case matters quite a bit, right? And that use case would determine how much decision authority you want to even give the tool, right? I think when we know less about the uncertainties within these tools, within these models, I think it's good for the engineers. And both of you mentioned almost use as a co-pilot, right? Let's monitor. We still have a lot of advantage of using these tools that we can still take the advantage of the time advantage and the complexity we can try to reduce. But I think providing decision authority could be a future step where it is consistently proven to meet it, be correct, and where we can maybe start building some argument that, again, to your point, Jody, on 5469, right? Like, can we show confidence in use that this can be known to make good decisions over a long period of time over different teams. So I think that is an argument I think we can build over time before we provide decision authority to tools, I think.
Well, I mean, I agree also. Transparency is also it's tricky, and if we pull back to autonomous vehicles as well, but I do think it's critical, and I think we see in, I know both of you follow, technical blogs that come out and articles that come out, but anytime, autonomous vehicle X company has an incident, there's a lot of screaming out there. Be transparent of, what happened, why did it occur, why didn't you detect this? And I mean, transparency, there's a lot of folds to that, like, being transparent on what training data we use or what assumptions we made and what processes we're following. And I think, there's a high level of expectations for ADS companies to be transparent, right? And we see that from the public requests, and at least today, right? Like we always talk about this around 40,000 fatalities a year in automotive, just in the United States. We wouldn't accept 40,000 fatalities with, fully autonomous vehicles. What is that number? But there's kind of a cry or a demand from the public to be transparent. So I think the expectation on tool vendors, especially AI tool vendors, should be there as well. Um,
And I think that's, the part of transparency that we can, that's within our control, are to share as much as we can, or for an organization to share as much as they can about what was their intent, what was their design, how did they train the model, what was the model's inputs, what were its outputs, how is it validated. These are places we can be transparent, right? It's a human statement of transparency. I think if we go to the AI model, deep down in there, it doesn't speak our language anymore, and so it's not going to bring transparency to the table itself. So we humans running our human run organizations have a commitment to that and share that sort of thing that's like publicly understandable, and that the public and regulators and shareholders, investors, employees, everyone can understand, right, and can get their head around. That's what transparency ultimately will have to mean in these cases.
Okay, great. Well, I mean, this has been a great discussion. I think a lot kind of we're leveraging a lot of our experience also, supporting the safe development of autonomous vehicles and ADS systems. I guess as a closing question, for both of you and whoever wants to be brave and go first, you can choose to go first. But what advice would you give organizations just kind of beginning to integrate AI-based tools and especially if it's safety critical development, and maybe break it up into two parts if you want. I mean, we know, let's say for autonomous vehicles, we always, you should have a driver in, right? A safety driver kind of in the beginning as a step one. And then, after a certain point in time, when you have high enough confidence, maybe with really restricted ODD, you can take the driver out. I mean, maybe it's a multiple stage approach with AI tools, but what would be the advice you'd give organizations just beginning to integrate AI-based tools into their development?
I can quickly take it. I think it's something that's on, of course, all of our minds, right? Internally, we talk about this quite a bit. Um, like the worst thing to do is to do nothing, right? It's interesting. We hear this term shadow AI. It's because of incentives internally or culture, all the things that we think about, right? People are using these tools, whether it's been approved or not, they're using these tools. I think a good organization would encourage people to tell them, hey, where are you using it? Where are the advantages? Let's inventory first, right? Let's not put a lot of pressure on ourselves at the moment. Let's inventory, let's understand where we use it. And then it's sort of really in a case by case basis. like where are the advantages, disadvantages, and also where should we actually build guardrails and where don't we have to build because it's not taking decisions. Maybe those can be less scrutinized, right? I think that'll be a good place to start before we get to the solution. I think where we see a lot of companies sort of finding out is when they just inventory, they find a lot of things to try to solve.
No, yeah, no, that's, I mean, Gokul took the best answer, so I have to have a second, my second runner up has to suffice. For sure, like lead into to getting started rather than like putting your head in the sand is a good one. I also think that sometimes there's a misconception or maybe a conception built in an earlier time that doesn't hold very well today, that the process frameworks in all these standards, are dinosaurs that shackle us and hold us back from doing things in a way that's fast and agile. And I think it's not that way, or rather, it doesn't have to be that way. Um, if we want to have fast, agile, modern development, as happens in modern organizations that build a lot of software-enabled things, we have to then take these frameworks that are developed for tool confidence is one of a few we've talked about, and we simply have to put it on that same relatively agile, relatively lightweight, and relatively modifiable track. And so that means that if we need to get out there, rate all our tools, and talk about which ones we have confidence in and which ones we don't, let's do that. And let's not make that a year-long exercise. Let's do a quick, as Gokul mentioned, a good inventory and see where we stand. And then let's build up evidence to be able to evolve what we know over time. I feel that if we say our development is at the speed of Agile, but our safety is at the speed of compliance from the 1990s, right? It doesn't work. And to the extent that we put ourselves in that position, it's on the organization. The safety portion, and in this case, as we're talking here, the tool qualification, the tool safety aspect of that, it has to be able to move and be agile along with the rest of the development. It's not separate. It should actually just be one integrated exercise. And part of what goes with that, the sort of practical takeaway from that is when you need these methods to be agile, install them in an agile and lightweight way, right? Get started with them, put them in place in a way that's able to accommodate the sort of quick turn churn of the world that we're in, and evolve them over time. Just as the code evolves over time, so too do our compliance arguments, our safety arguments, and so too does our tool qualification. I think when we keep that kind of idea in mind, things that we know in terms of frameworks are highly applicable, even in the sort of AI dominated world that we're all in now.
Yeah, I mean, I agree with both of you, and I think we can't forget the techniques and methods that we'd use even for a non-AI based tool have to be applied and just maybe with more visibility to it. So, I mean, what I mean by that, if I'm using it for developing C code, I mean, state of the art of best practices is you have a static analysis tool, right?
Yeah.
So if you're going to use an AI-based tool to help develop C code, then you must have a static analysis tool to validate it or verify it, right? Like those things don't go away because of this, they actually strengthen. So I think a lot of the things that we prescribe for non-AI tools, we just have to enforce harder. And this is process oriented, making sure the right tools to check on it. As we mentioned before, really intensely verifying the output, whether that be human in the loop. One thing that maybe both of you kind of mentioned or kind of talk about a little bit, but we've done this in the past, especially when 26.2 was first introduced. Talk about pilot kind of activities, right? Maybe run things in parallel because I think with safety analysis, as a safety person, I'd be very uncomfortable just saying, hit a button on a tool and then the output and there's my results and now go develop that. However, I think a AI-based tool for safety analysis probably generate a lot of things we didn't maybe think about too, right? So maybe we can run in parallel. If there's, if you have that luxury to have a group kind of running a safety analysis, that example, and have the tool run it and kind of do some comparison of results too. Or, as Bill mentioned, the kind of the co-pilot idea, using that also to support. So, all right, great. Any last comments or?
It's interesting. I keep thinking about this example you gave with Ollie, right? Like, did you use any big words in your requirements? Then maybe your tool should be pretty suspicious, right? why did the steering requirement have like the most flowery English language, right? Maybe
Yeah.
we need to look for them. I keep thinking
Well,
about it once you mentioned that.
and they had a process set up there because I was the boss kind of in that sense. The teacher texts me, or we get automatic text notifications, and he got a 0 on it. And in the comments was written with AI, and I knew. I mean, my son's still a boy, right? A young boy, and I was a young boy too, and done a lot of stupid things in my life. So, but I know he wouldn't intentionally kind of like try to break the rules. So, when I started reading through it, there's two versions of it, him handwriting it out, and like, okay, that sounds like him. And then I read the next version, like, Ollie, whenever in your life have you ever used that word, right? Like, do you even know what that word means? It's kind of human in the loop. Me being a human in the loop is a pretty easy spot check to find those things. So,
I mean, that's again, that's where we are, right? AI is if you're on a screen and you're interacting with something, AI is just there, right? And the idea of stamping it out will never work, right? So that human in the loop is really important because AI is for sure in the loop. Whether you requested it to be or not, it's there. So
yeah.
yeah, human oversight is not a bad idea.
Yeah. All right. Well, thank you, Gokul Bill. Thank you for everybody that tuned in. We'll have another fireside chat sometime later, maybe next year. I don't know. But yeah, reach us on sres.ai, and thank you.